So what is MinIO for those of you who don't know us? So MinIO is a high-performance object store, born in the cloud, Kubernetes native. We're designed for very, very large-scale infrastructure, so enterprise-grade infrastructure. 100% open source under AGPL-v3. And we were built in the last 5 years. And so basically, we were built for the cloud operating model, right? And one of the things that we'll talk about today is the cloud operating model, because the cloud is not a single place. It's not the public cloud or the private cloud or even the edge cloud. You know, the cloud is all of those things. And so it doesn't really matter where you run your workload from that perspective. It really matters the fact that you're using the principles and the concepts that effectively drive the cloud operating model. And that's something that we see time and time again as people look to modernize their applications, as enterprises look to basically upgrade their overall infrastructure to be more nimble, to be more resilient, and to be more secure. It's worth noting that MinIO only does one thing, right? The team here has a lot of background in the storage space, but when they started MinIO, they thought to themselves, what is the problem that we want to solve, and what's the way we want to go about solving that problem? They saw the cloud as being the primary challenge to go solve, but more importantly, they said that object storage was the way to do that, right? So this is the same team that built GlusterFS, right? One of the most successful file systems ever. It still runs and is still available through Red Hat. But when they went to go construct something new, they looked at the model and they said, is that going to be viable in the cloud? And they determined that it wasn't. And so we do object storage. It's the only thing that we do. And we aim to do it better than anybody else on the planet. It's worked out very well for us over the last number of years. We are probably the most deployed object store in the world. We're certainly the most deployed cloud object store in the market today. We have more than, I think at this point, 850 million Docker pulls in total. You can see that on our website, and we track it on a daily basis. We're doing about 1.3 million Docker pulls a day to give you a sense of what the volume looks like from MinIO. We're on every single continent. That includes Antarctica. We're actually, we have multiple deployments in Antarctica of note. And we are, again, we have dominance in sort of the big enterprise deployments across the Fortune 100. We have about 77% penetration. We also have similar penetration across the global 100. We have 10 of the top largest banks in the United States run MinIO. 7 of the largest 10 defense contractors, 7 of the largest 10 retailers, 9 of the 10 largest pharmaceutical companies in the world. And you get a sense of what that scale looks like from a growth perspective. And it's something that is facilitated by our model, right? So AGPL-v3 is easy to download. There's very little friction associated with that. You're free to inspect. You're free to modify as long as you're inconsistent with the license. And that's allowed us to really get a very, very broad set of market penetration and then grow that in from a commercial perspective. So what are the guiding principles that drove us to this place? So 3 things that we look at on a constant basis from MinIO's perspective is, one is, what is a high performance object store able to do, and what does it look like, and how do you architect that? So we've always been focused on performance. We were one of the first companies to actually produce performance benchmarks. We continue to do that today. Our most recent benchmarks clock in at 345 gigs a second on reads and about 160 on writes. And that's on 32 nodes of NVMe, right? And we publish that, and you can go actually mimic that on AWS for less than $300. It takes you less than an hour to go check our work on that, right? So that makes us the world's fastest object store. And it's not just a vanity metric for us being the world's fastest object store. It actually matters in terms of the types of workloads that you can run on object storage when you are that fast. And so that allows object storage to step into the role where we are basically able to run databases, right? We're able to run AI ML applications. We're able to run modern web applications and do that at scale. The other part of it is that you have performance is one thing and scale is another, but performance at scale is what matters to the large enterprises today. So the ability to be fast at many, many petabytes is something that's very, very different than I'm just fast or I can just scale from an archival perspective. They're very, very different concepts. We're focused on performance at scale. The other element is simplicity, So one of the things that comes into the cloud operating model is that complexity can become a challenge. So we are focused on making our implementation of object storage for the cloud remarkably simple. And we're going to show you that today. Right? And I think the third point is that cloud native. So again, born into the cloud, we have always adhered to the principles that drive the cloud native operating model. So that's containerization, that's orchestration, right? That's APIs, that's automation. Those are the things that drive us. Those are the things that we think about each and every time that we look at features, that we look at different elements of what it is that we do. And it's important because if you really want to be cloud native, you're going to have to be on every single cloud. That's the challenge that the enterprise faces today. Every single day, there's another piece of research that comes out that definitively shows that the large enterprises today are multi-cloud enterprises, whether by design, whether by accident, or whether just by M&A or evolution. They are all multi-cloud. They're running multiple private clouds. They're running multiple public clouds inside of their organizations. Even the large organizations like Capital One, who claim to be, single cloud only, we're only AWS, you'll find that they have tons of MinIO running there, right? They have large private cloud instances that still exist. And so to be truly multi-cloud, you have to be able to cover all of those clouds: public, private, Kubernetes distributions, colos, edge. Every one of those environments has to be there. And so those enterprises that are demanding the multi-cloud world are doing so for a number of reasons. So one is that while AWS is clearly a great model, it's somebody we look up to, they're only available inside of AWS, right? AWS isn't available inside of GCP. It's not available inside of Azure. All of the public clouds are fundamentally incompatible with each other. The Azure Blob API is not the same as the S3 API. There are similarities, but they're not the same. And so your application can't run across those cloud environments. And it's certainly not the same as Tanzu. You won't find AWS on Tanzu, and you won't find it on OpenShift. People want application portability. They want the ability to move their application from cloud to cloud to take advantage of the cloud as infrastructure without having to make significant changes to that application. What they really want to do is they want to update and refresh their bucket names. And that's what true multi-cloud offers them, is the ability to have leverage from a business perspective, the ability to have portability, and the ability to have continuity. So cost is a big driver of this. If you treat the cloud for what it is, which is infrastructure as a service, you can actually take advantage of the cost advantages there. If it's a better deal to run NVMe on GCP, you can move your application over there. Because as applications mature, that's when you start thinking about optimizing for different things. We often tell our clients, listen, go to the cloud, learn cloud muscle. But once your application matures, you understand the construct and the behavior of the workflow and the workload, that's when you start to think about optimizing for other things. And that may be cost, that may be security, that may be continuity. And that's when you should start thinking about where you want to move it to. Continuity is a big piece of this. As we've seen in the last number of quarters, clouds go down. If your business is entirely built on a single cloud and that cloud goes down like it did in December for AWS on multiple occasions, that has material impacts for your business. If your entire business depends on holiday sales and it goes down in December, that's a huge issue, right? So cloud continuity is the ability for your application to fail over gracefully to another cloud and continue to run, right? It seems like a giant task, but it's available to you today if you architect correctly. So these are the things that, that build up basically why the enterprise is demanding multi-cloud storage. The last piece I think is worth noting is that from a multi-cloud requirements perspective, you often see regulatory requirements driving the bus in terms of how this happens, right? There's data sovereignty issues. There's also issues around specific regulations, whether they be financial or healthcare related, and that's often driving a multi-cloud decision-making process. The object storage landscape today is actually relatively, it's balkanized. You have the hardware appliances, which don't have a path forward in the cloud because you can't containerize an appliance, something that we've spent a lot of time talking about, but it's just a fact, right? You can't containerize an appliance. You have the storage as a service, right? We talked about AWS, but AWS doesn't run on Azure. It doesn't run on GCP. It certainly doesn't run on Tanzu and OpenShift. And then you have software-defined storage, right? That's the area that we fit in as well as some others. But software-defined storage gives you the flexibility to run anywhere. And when we talk about running anywhere, we talk about every single cloud. We talk about any piece of hardware. The binary for MinIO is less than 100 MB. We fit on the size of the head of a pin, right? That means that we can fit on a Raspberry Pi, right? That means that we can fit inside of a 5G point of presence. That means that we can fit on board an autonomous vehicle, a drone, whatever it may be. And we can also power the data center. So software defined is a model that we adhere to and we think is very important as you think about what a multi-cloud architecture looks like. So when we talk about that, we talk about marketplace offerings, right? So you see things like every cloud being in their marketplace, being certified for every one of those solutions. And we'll posit today that we're the only company that can actually make the claim and show and prove that we are on every single cloud. So we already have 1 million deployments across Azure, GCP, and Google today. 1 million deployments across those clouds. I'll tell you right now, that's more than they have collectively for their Anthos stack and Outpost on the private cloud. But in addition to that, that's all roll your own developer-led growth for MinIO. In addition to that, we've also recently added a whole suite of marketplace click-to-deploy applications where we've done all the work around trying to figure out what is the best implementation for a performance or a density situation for you on all of these clouds. We looked at hundreds and hundreds of instances to come up with what our opinion is as to what the best one is, so that you can go to that marketplace, you can click on adopt MinIO, and you can download and run MinIO with just a handful of configuration elements, like how big you want your cluster to be and what kind of security you want. So you'll find us today on Azure, AWS, GCP. Those things are all blue because they're links, right? You can click on them and it'll take you directly to our marketplace. You can go to our website, you can go on and go directly to those marketplaces. We're also on Red Hat. We're also on VMware's marketplaces as well. So again, you can transact MinIO directly on those websites. And so that's a very high bar, right? You have to go through a lot of hoops in order to earn that, but we went and did that work because we wanted to put our money where our mouth was when it came to saying we actually do these things. And we have a bunch of real world proof points from that. So I'm just going to give you a handful of those. So the first one is Freddie Mac. So Freddie Mac runs MinIO inside of AWS. This is the same team, by the way, that came from Capital One, and most famously the AWS shop. But what they wanted is they want greater control over security. They want greater control over cost. They want greater control over just the overall process. So the regulatory environment for a federal agency to go into the cloud requires multi-cloud, right? And so when you require multi-cloud, it means that you have to have the ability to move from cloud to cloud. And the only way to do that and retain your security componentry, or to retain the governance and identity and access management componentry, is to adopt something like MinIO as the data store. So that's exactly what they've done for some of their AI and ML workloads, and will expand over time. You have someone like Rakuten Symphony, who has basically completely changed the way that the mobile world is constructing networks, right? A very open, software-defined mobile network, reference architecture that's available and adopted by some very, very large telcos out there. I think they're in the over 50 at this point, global networks that have adopted this approach. So they wanted to build on top of an open, software-defined object store. And again, whatever cloud that may run in, which will be different for each and every one of these telcos, they needed something that would be extensible to all of those environments. And sure enough, they adopted MinIO for that, and they've spoken publicly about that. The last is Box.com. So Box has also spoken publicly about our work together. So if you think about what that next generation workload looks like, performance at scale, right? A Splunk Smart Store is a perfect example of that, right? So they're running tens of petabytes of log files inside of Box, because from Box's perspective, the most important data that they hold is not your data, it's the data about your data, right? And so that's what the log files allow them to basically consume and evaluate. And so this is a huge component part of their plan. And so they run MinIO in that environment. It's a private cloud environment. but it's designed to take advantage of that very modern approach of disaggregating compute and storage. So Splunk acting as the compute layer, MinIO acting as the storage layer, and then delivering performance across tens and tens of petabytes.